Hello everyone, how are you all? Welcome back to the another video. I hope all are you good and learn something new with day by day. So today we have another study case. Right now this phone come to me in a dead condition. Right, when I diagnose this phone, it's not in a dead condition. The customer told me this phone is a dead condition, but when I diagnose this phone is turned on. There is a LCD related issue. No graphics, no light. The LCD had issue. Right, when I connect the charger, it's taking charge, and I connect the on switch, it's vibrate, but there is no display, no graphics. Right, so today we diagnose this phone and I'll show you the process how to repair, right, this kind of the fault with the no display, blank display, no graphics and the light, nothing. Right, so today we diagnose this phone and let me see repair. Now when I look at the motherboard, there is look like no one work on it, the all shield were intact. Now remove the connectors and let me check the other side. Now on the other side, only just a shield removed from the CPU side, otherwise no one work on it. The motherboard look like a clean, proper, no damage, no one work on it from the either side. Right, only just the shield removed. Right, it's look like a fine and also not like a drop down case. Right, there is no drop down case look like, but let me diagnose this phone. Right, so testing start with the diode mode. First of all, fix this phone with the frame and connect the charger, or basic testing. Right, so we connect the charger on the right side, on the upper corner, the charger, and when I connect the charger, the reading start. Right, sorry, 0.9, right, and 0.4 and 1.8. Now phone charged, but there is no display. Right, our display totally blank. Right, also not the no graphics also. When we look at under the light, still there is no graphics available. Right, nothing. Right, so and it's look like nobody work on it, but still when we press the on off switch, there is a vibration also. Right, that means the phone turn on properly, but the blank display issue. Let me check the PCB, remove the charger. Now we remove the PCB, I mean to see the connector sides, and check the one by one, step by step, the diagnosis process, how to diagnose. Right, from the diode value to voltages mode. So remove the connectors. We first start the diode mode value. Right, for this we open the Borneo. In a Borneo we open the Redmi 13C, because the Poco series M6, this one model, and the Redmi 13C are similar. So open the Redmi 13C. See 5G. So this is a 5G model. We open this, and first of all we open the LCD side, because whenever a phone is in no graphics, right, no graphics, first your job work start with the graphics side, LCD side. Test all the lines, right, according to step by step, because if your graphics is okay, then we work on to the light section. So our first job, check the diode value one by one, each and every. See line open, the diode value, we have to confirm which line is open. After that we goes to the voltage. So this is your LCD IC. This phone had no schematics. only a bitmap and the hardware solution. So we just test according to the hardware solution. If any case, a bitmap. So this is a hardware solution. Oh, so this is a LUBIC or graphic IC. Okay, so we test one by one each and every line. So first of all, the MIPI lines from here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so total 12 lines. After 2, 1 ground, right? So it will be easy from the downward side. So test. So we go to the microscope camera. Okay, so camera, and this is the connector. So this one is a connector. Okay, now the multimeter on your upper side on a diode mode, right corner upper side on a reverse bias with the red probe ground and with the black probe. You have to test from this side. You have to 1, okay, 315, 2, next one ground, okay, 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 ground, okay, 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 ground, okay, okay, ground, okay, okay, and the ground, okay. So here it is, the MIPI lines according to the diode section is completely okay. Now we move on to the next, and we go to the Borneo again. After that, there is a lines called LCM. After the ground, next one is VIO 1.8. Check here on this capacitor, right? So go to the microscope again. Okay, so here it is. This one is reading, and this one is, in just a second, this one is a ground, okay, and after that this is a NTC, LCM NTC. So there is a diode value also. After that, on this capacitor, a 1.8 voltage, right, a VIO 1.8, and this same voltage will be on this side, no, this side, yes, this is a 1.8 voltage, right? So after that, we again go to the Borneo for further lines. From here, 2 lines from VSN and the VSP called AVEE. Let me test one by one. So this one is 1.8, and the next one is VSP and the VSN. There is a VSP, okay, 511, it's okay. Now we check the forward bias, this line. Okay, this is VSN and this is VSP, right? This is maybe I'm confused just. So we check directly, we go to the again Borneo, right? So we check here on these 2 pads, right here where there is the under the resistance, the last one, silicon form, right? We go to the microscope. So here on this point one point is here. So this is a VSP and this is a VSN. There is a OL. Now VSN is a negative, right? So we can only check on a forward bias for the reading, right? Not on a reverse bias. So we reverse the prop and on the forward bias, okay, there is a similar value. Now let me check on a VSP, or you can say AVEE, right? Now it's okay. There is no shorting and the both readings are okay. Now we test further. Again go to the Borneo. So we go to the Borneo. Now after the VSN and the VSP, or we call AVDD, AVEE, both lines are okay. Now we check the tearing effect and the reset line on these capacitor resistance, the green line and the orange line. So we go to the microscope, right? On this resistance TE, so 876, okay. On this resistance the reset line 877. So according to the graphic section at the LCD, all lines are okay, right? There is a no line open or shorting, right? Now we can check for the voltages either, and we also check, first of all, after that we check the, let's say, light section, right? But according to the sequence, we first check always the LCD. After that we move on to the voltages, right, or the light section. So we check the light section, maybe let's say test the light section in a diode mode. After that we combine, check the voltages for both sections, which line had a problem. So we go to the Borneo again. Okay, so this is a 6-leg light IC installed. At this one is point is anode. After 3 points connected with the cathode and the CABC, 1 2 4 5 6 7 for the CABC, 1 for the anode. And we move on to the microscope. Now reverse bias, similar testing with the black. So this reading is anode line on 1.5. So this is abnormal, right? This is abnormal. On this point, according to my experience, there is a 500 something reading, right? There is something wrong. Let me check on a reverse bias, forward bias. So 1.8. So still there is a line open, maybe anything, right? Now we check the, on a forward bias, the cathode, 1 2, this one cathode, this one cathode, this one cathode, okay. Now the 7 line, this one is 1 2 3 4 5 6 7. This is CABC, okay. 1 2 3 4 5 6 7. So the CABC is also okay. But the anode reading is little abnormal. Now look at here, there is something missing here, right? Any component, look like, which component is this? There is a ground and this side is a reading, so there is a capacitor, so no worry. Any filter cap here. So go to the first Borneo again. We cut it shielded from, right, after the both ICs are open for me, so we can easily test here. So we take a drill and open this from here, this, cut it, go to the top cam. Now shield, is a water intact here in this phone, right? So when we go to the, look at here, this phone had a water logging, but on the upper side there is no water sign. But when we remove the shield, look at here, all these are water. Due to this, I think this had a problem, right? So first of all we remove it, I mean to say clear this water with a thinner, right? And after that we test again, right? So top camera, it's anything clear, right? So this is your graphic IC, this one, the graphic section, and this one is your light section, right? This is a coil, light IC, diode. So we test again here the anode line, still it's same or not. Multimeter on, multimeter on a reverse bias, the anode line. Now it's completely open, right? Now it's completely broke open here. From here to here connectivity, yes, but there is no reading here, right? So we go to the Borneo again. So this coil, out this capacitor, then on this coil, look at here, this coil, I think this is a properly burned, right? This one right here. So on the capacitor we had right reading on this side, on this side no. I think there is a problem, this, because the anode line is a high voltage line. I will explain you later in this, after when I complete this, explain you about this. Okay, so I think we remove this. After that we test it. Okay, all right, so now we test here. Okay, on that point there is no reading, there is no reading both side. Okay, we go to the confirmation, we just clear this. After we check on a directly to the now we again go to the Borneo. So from here to here there is a big capacitor. We check here on this capacitor with the yellow line reading here, but on the both side burn, the track is burned, right? We focus, let me Go to the scope and zoom it. Can we see anything? Okay, let me check the connectivity. So one probe on a capacitor on this side, no connectivity. So that means, again, so that means the track is burned here. So we take jumper from here, from this capacitor, right? We get a value. Let me check again. On this capacitor we have a value, a die value. The line is proper here. On this line, that voltage is here or not, that is the another point, right? So we take jumper from here to the anode on the connector side, right? So first we connect a jumper. Okay, okay, on the jumper on here on this side. We take care properly because this is a high voltage line. Okay. Now we connect jumper from here to here, right? Microscope and again so we jumper here actually, right? So we jumper here on this capacitor. I will show you. So we jumper here on this capacitor. I will show you in a born new. Look at here. Now this anode line connected with this capacitor. I take jumper from here to on this capacitor right here. Now we check. Okay. Now we check again. Now we check the diode reading, the connector. So take a multimeter again. Okay. So now we get a value here, right? Now we pack the phone. There is a till display. One thing, check the voltages. This line. Now we go to the board. Now then the LCD section. Capacitor, this one, 2. Okay, check here. So we go to the microscope here. Now we check the graphics section, voltages. Right, now we check again. On this capacitor. Go to the again Borneo. The straight one of the IC. I think there is a water under the IC. Okay, there is a no voltage. Let me check again. Let me check the reading on a diode mode. So 466 OL. So do one thing. Okay, maybe water log. Water. There is a water inside the. Okay. Do one thing. Just remove. Wash it. Put it back. It's microscope camera. So this I see. First of all, we clear this. Any pad burn? Look like look like this pad is burned right here. So let me heat up a little bit. So for the confirmation, we little flux. Right, this pad is burned. Okay, this one, this pad is burned properly. Right here, this pad is burned. Okay, now let me check the pad on board Neo. This one, 1, 2, the equal pad. Now, the VPH pad. VPH. Okay, so this pad is burned under the IC. Okay, so we scratch here and see there is a pad value here. It's another pad also. We check here also. Things like Now I just fixed this phone, right? Before you see, already this IC had a, when we removed this IC due to water logging, this IC had internally the pad broken, the VPH pad broken. So we repair the pad and replace the IC because the previous IC is also not in a good condition, right, due to burning. Also we work on previously this light IC, I mean to say this jumper here, right? Everybody know we take a jumper from this line open already, the anode line open from the connector. So we take a jumper. Let me explain you again how do we repair this phone in a completely way. First of all, I tell you, we replace this LCD IC, right, because there is a VSN and VSP, both lines are missing, +5 voltage and the -5 voltage, AVDD and AVE, right? Secondly, the anode track open. So we take a jumper. First we take a jumper from here to the connector side, right? But when I fix the phone, right, I see the display was blinking, right? Then I replace this capacitor, because before you see, I will show you. We replace also this capacitor because the previous capacitor, this one, is completely burned, right? Somehow it's work, but if we did not replace it, because this is a filter cap and this is a high voltage line, right? If we did not replace it in future, because this is a high voltage line, the chances are high it's leakage or short due to again this line short, right? So we replace it. So I thought the blinking was, the display was due to this filter cap, but the blinking was retained same. So what I'm doing, right, I just open the display, right, and directly jumper from the anode line under the display, right? I will show you in a top cam. So I take a jumper from this capacitor, the anode line, and directly connect with the display anode on the strip under the display, right? So we will fix this phone, right? I will show you, and after this I will explain to you how I repair this phone, right? Each and everything. Now I just connect a charger here. And the charging start, and the POCO, right, the logo will appear, right? The charging 1.8 ampere, clear? So battery logo appear. Now we charge the phone on the turning on the phone. Okay, so the logo will appear. Right, now I will explain you after turning on the phone in a completely way from starting to till the end. What are the steps? You already seen when we first we work on an anode line, right? After that we work on a graphic IC, the pad internally damaged, right, due to water logging, the pad burn. The phone turning on properly. Okay. Okay, now the phone working properly, right? Now I'll give you some insight, I'll give you a learning. Now I'll give you some explanation about this phone and also the insights. Now this phone come to me in a dead condition. Okay, so when I diagnose, there is a LCD issue. When I connect the charger, it takes 1.8 ampere. You have seen this in a video. Also, when I press the on off switch, right, it vibrates. That means it turn on, right? So whenever a dead phone come to you, it's not properly dead. Sometimes it's related to the charging issue. Let's say due to low battery, phone had a charging issue. Due to low battery, it does not turn on. So according to the customer told you the phone does not turn on, it's automatically switch off. So diagnose properly. If you did not diagnose, like there is a charging issue or LCD issue, and you work according to the dead, directly jump on the according to the dead section, right? Maybe you could not repair the phone, right, or even harm the phone. Now this is a basic one. Okay, now talk about this problem, right? So whenever a phone come to you which has a blank display, no graphics, no light, totally blank display, what are the process? First of all, you have to work on LCD section, means for the graphics, either the AMOLED phone or the LCD, right? You first repair the graphics, means your basic testing start from the graphics, the diode value and the voltages. After you go through the light section, means after you jump on the light section on a secondary basis, your first job work on a LCD related. Now talk about this, right, on a blank display, okay, or you can say screen, right? Number one, first we check the diode value on LCD section, like your MIPI lines, right? MIPI lines, tearing effect called TE, reset, VIO 1.8 volt, and VSN, VSP, or you can call AVDD, and the AVEE, plus 5 voltage and minus 5 voltage. All the diode value, I'm talking about the diode value. The diode value is correct. There is nothing. Now there is a shield, the both ICs, right? The LCD, your graphic IC, and the light IC under the shield. For the testing purpose, right, the voltage is testing purpose. So I thought first take a diode value on the light section also, right? When we check the light section on a diode mode, right, I saw a node line, the positive line. Anode is a positive voltage line, had open, right, the abnormal reading 1.563 around about. And normally you have see a 550, 500, 550 roundabout according to the multimeter to multimeter, right? So this is abnormal. So we cut the shield, and when we cut the shield and after that again testing, because we have a doubt on this line, there is a fault clearly. When we check again, right, this line is completely open, no value. So this is open. When we diagnose, there is a coil, right, it's completely burned, or you can say the damage, right, from the both ends. So near about the filter cap, a high voltage filter cap, there is a diode value, a correct diode value. So we take jumper from cap to connector. Now when we connect the jumper, the voltage start, but there is a 3.7 voltage on this line, basically a VPH voltage. So the IC connected with the coil from two ends, right? After the switching, there is a diode connected here. So this is the positive line. Now somehow the switching does not start. So whatever the voltage on a VPH, it directly passes on a positive line. So that's why we see in the filter cap, or you can say the jumper, when we connect the jumper, right, 3.7 volt. If you see properly video, you have seen 3.7 voltage. Now when we see the 3.7 voltage, that means the light section connectivity is okay, but not the switching. Now remember again, I've told you your first priority is LCD. Also when we open the shield, right, we saw there is a lot of water, water marks, or logged water, right, or dry water, or you can call whatever you call according to you, right. Due to this, the anode line open. Now I'm removing this, right. Due to this, anode line is open, because in anode line you get a 15 volt to 40 volt. So this is the highest, means the highest voltage line in mobile phone, right, in phone. So that's why whenever the water locked, this line always short or open, because this is a high voltage line. Now we repair this line, right, the connectivity will be okay. Now we move on to the LCD section again, because there is a waterlogged phone. The phone still does not work. The problem same, a blank display after repair, after the jumper. So you can say we find the first fault, right, but the phone does not repair. This is a waterlogged phone, right. So when we remove the LCD IC, under the LCD IC there is a, due to water logging, the pad burn, right, pad burn, a track open properly, the pad burn. Now this pad belongs to the VPH switching line, right. The VPH connected 2 volts, for the one for the VPH directly, other for the after the coil through the switching line. So one of the line is on a VPH side, the pad burn. So due to the pad burn, the IC does not respond or does not switching. That's why the LCD IC produce AVDD and the AVEE voltages, like -5 voltage and the +5 voltage. Now these two voltages does not generate. When we measure these voltages does not available. That's why I remove this IC. When I remove this IC, we see there is a pad burn. So our first job, repair the pad. When we repair the pad, and when we look at the IC, somehow the recording will be stopped, but the IC also does not in a good condition. So I replace the IC with the another motherboard, right, a new IC, we replace it. After replace it, the pad was also repaired. Now the anode line also jumper it, right. Now after connect the battery, when we plug in the charger, the logo appear. I tell you the whole story and the insights. After there is a blinking or display blinking. Now display blinking is the mainly reason for the coil. First of all, also the filter cap, because in this phone the water logging, so the filter cap after the diode, this is also not in a good condition, right. So I'll change this capacitor, because I doubtful on a capacitor, so I will change, but still the display blink. Now I open the display from the frame, and in the frame you have seen there is a positive, minus, right, anode, cathode on a display strip, a light strip on a display. When you open the display, there is a light strip. When you see right? There is a positive cathode. So we take a jumper from the positive, and on the motherboard, the capacitor, we take a jumper here, connect with this, right? Now there is a 28 volt when I measure, right? So after connecting the jumper, the display is stable. Now the question is how the display is stable, right? After the jumper. Now this is a waterlogged phone. Water also logged in a screen, right? And anode line on a display side is a heavy line, a heavy voltage line. So when the water logged due to the short circuit or the high voltage current, right, somehow the flex between on a display connector, a display flex connected here, the anode line is weak, right? The strength internally is weak. So when the load, a 28 voltage load, comes to on this line, on the flex, right, the display blink. So I will connect with the direct jumper. Now the insights, right? What are the process? I mean to say, what are the basic learning after this study case, right? So whenever a phone come to you, your first job, if the phone comes from the LCD, a blank display, your first priority, work on LCD, not in a light section, work on a LCD section. Check the diode value each and every point, right? Step by step. If any line open or short, repair the line, right? Second, after that, go to the voltages, like first of all AVDD or AVEE. These two voltages produced by the graphic IC. Check this. After that, VIO 1.8 voltage. After that, the reset T, like this. After you move on the light section. Okay. So I'll show you the whole process. I hope you like this video. I know according to the editing, or you can say the recording wise, this video is not good, but I hope you will learn something from it. That's why I upload, right? When we look at the recording, that is not good, right? But when you look at the content for the learning purpose, it will be valuable for you. Now we will meet you in the next video. I hope you like this video. If you like this video, please comment, right, on this video, right, and share this video, because if you share this video, comment this video, like this video, this will motivate me. Thank you so much. We will give you another lesson soon. We will meet you in the next video. Thank you so much. Bye bye.